Welcome back, everyone, to this last session of our ROS Industrial Conference of this year. So I'm very excited to actually have this session. So we're going to talk about ROS2 and Industrial. And with me in the session are Leonard Puck from SwRI and Catherine Scott from Robotics, as well as Matt Robinson from the ROS Industrial Consortium Americas, as well as Southwest Research Institute. And the first talk that we're going to hear today in this session is from Leonard Puck from SwRI, who's a researcher there, and he will present to us his work on real-time with ROS2. Leonard, the floor is yours.
So yeah, today I'm talking about distributed and synchronized setup towards real-time robotic control using ROS2 on Linux. Yeah, as already mentioned, my name is Leonard Puck. So yeah, first maybe a short introduction of me for you who don't know me. I'm a research scientist at the SwRI Research Center for Information Technology, which is located in Karlsruhe, Germany, so close by basically. And my main research topics are normally risk-aware robotics, hazard perception and anomaly detection, and especially on the walking service robot LARON 5, which you can see at the bottom of the screen. But yeah, today at the ROS-I, I will talk about the capabilities of ROS and ROS2 especially, and how it might be used in robot control later on. So yeah, the goal of our study was an evaluation of the real-time capabilities of ROS2 from the future development of a distributed robotic controller. So today I'm going to talk about the preliminary steps. So they are not that ROS2 specific, more like a system setup to have a system which enables real time. And later on I will talk briefly about the evaluation of ROS2, what our key findings were, and how to set up ROS2 applications that they are real-time capable. So this is all towards the goal that we have a distributed and time-synchronized robotic controller later on. So yeah, first of all, let's talk about the system setup. Since we are talking about real-time, it's always necessary to know the hardware and system we are on. So here you can find the listing. Basically, we have an i9 core, and we are deployed an OS Debian 10. With a kernel 4.19 with a preempt real-time patch. At the time we did this research, the 5 series of the kernels were already out, but due to the OSADL benchmarks, we figured that the 4.19 kernel had better results, so we deployed the 4.19 kernel to reduce latency. And yeah, for the time synchronization, we used the precision timing protocol, and the hardware used was the OTMC 100i as the grandmaster, and we had a PTP time converter so that we get pulses per second, which then in the end we could measure by an oscilloscope. And furthermore, we deployed ROS2, the Eloquent Illusion release, and the underlying DDS was the OpenSplice Community Edition. If we have a look to the right, we can see our system setup. Yes, on the left, we have the Grandmaster, which basically gives us our reference time. So all our nodes are synchronized, and both PCs, they are set up the same. So they have the same configuration of the kernel and of the BIOS. And furthermore, we mapped the serial interface pins of the motherboards so that we could trigger them by mapping them in user space. So we introduced with low overhead a way that we could measure basically when an application is running. So the setup is that we have at the beginning the camera node and the object detection, which is basically just for the whole pipeline, which I will not go into detail today. And the interpreter then takes the pose, translates it into robotics coordinates. The interpolator then calculates a path. The local subscriber is just for testing purposes in the study, and the EtherCAT stack basically doubles as the remote subscriber. So I mainly will be talking about the local and remote publisher, which is an interpolator in our case, and the local subscriber and the remote subscriber. Yes. So first of all, from the time synchronization, as already mentioned, we use the precision time protocol, and we use it to synchronize both PCs and have the reference signal from the oscilloscope. And we expect a stable round-trip time since by design the PTP is easily desynchronized with network load, which we evaluated later on. So you can see once we have incoming network load, the timing will be off and the synchronization will suffer. So therefore, it might be beneficial to have a dedicated network for the synchronization. And this part of the study is already published. It was on the CASE conference this year, and the title was basically the same as this talk today. So then let's dig deeper. So from the system setup, first of all, we had an out-of-the-box system. So we had a clean setup of the kernel with a real-time patch, with the default values, a clean Debian 10 installation, and by default, which is a problem for real-time, the power save mode is on. Since we are on consumer-based hardware, it makes sense that power save mode is on, and we don't want to run performance all the time. And as you can see in the plot below it, we have latencies spiking up to 425 microseconds, which is for most real-time applications quite high when our system already takes that amount of time to respond. So we tried to decrease that, and the first thing was obviously enabling the performance modus, and you already can see we have a drastic decrease in latencies to a maximum of 38 microseconds. And furthermore, if all debug options are disabled in the kernel, we can go as low as 21 microseconds, which is similar to the provided OSADL benchmarks from the system. And hence, we figured our system should be able to run with real time now. So we thought everything is set up properly, and then we tried the provided ROS2 Intra-Process Pendulum demo. However, while trying that, we quickly figured out that the results really don't look right, since we had spikes all over the place of up to 80 microseconds in the histogram. So we figured, yeah, something seems to be not right, since it shouldn't be that high, since all the other tests we found on had lower spikes basically. So then we used ftrace to figure out what was going wrong, and this is maybe something we learned, since in Linux some BIOS settings might be ignored. So we directly had to set it in the grub, and we had to disable in the C state, so basically in the idle states the computer can go into. And once they were correctly disabled, you can see after an initial setup, the latencies drop to around 4 microseconds, and which is something we would expect, especially since we're in an intra-process communication, so there's no additional communication overhead. Furthermore, all of that is still stable once we employ stress on the system. So we have memory, core, and inputs all stressed, and you can see there are more spikes, but they still have a low latency. So this is basically the system and kernel setup we want to have. Then let's dig deeper into the testing we did. First of all, we had our ROS2 applications, and our first trials were what is to expected when we employ basically what's in the response time we want to have from them. So once again, both PCs are synchronized using PTP, and the oscilloscope furthermore is synchronized as well. And we use the time from the TICRO, so from the PTP Grandmaster, as our reference time, and we pulsed with 1,000 pulses per second, which is basically that we want to run with 1 kilohertz our nodes. So and therefore the aim was at each new millisecond, our node should respond as fast as possible. And we had a scheduled wake-up time at the millisecond, and later on for the other subscriber one with an offset, but I will go deeper into that later. And we set the real-time priority of the node to 95 with first in, first out scheduling for each thread employed. And then we had different test cases. The first was on an idle system where we used just our applications, no other processes running. Then a stressed system where we overloaded basically everything as well. Then we isolated 2 cores and had on the threads moved to these cores to see if we can seclude the ROS2 application from the stress we employed. And later on, we used shielded cores, one try with 2 shielded cores, one try with 4 shielded cores. Yeah, from the results, you can see them on the right. The idle one is basically our baseline, and as you can see, the ROS2 applications had on the idle system state a maximum response time of 43 microseconds. I'm mainly going to talk about the maximum since this is the most important if it's about real time. And since ROS2 is quite a complex application, we didn't do a mathematical proof, obviously, but employed long time tests. So these tests were each conducted over a night with around 1 million measure points of an oscilloscope. So the times seem to be fairly reasonable, and we don't really expect that there are outliers. So yeah, with the stress systems, you can see the maximum decreases slightly. However, it's not such a big impact from the response time. However, once the applications get larger and are not for just measuring, this might be affected a bit more. Once we isolated the cores, you can see that everything goes out of place and we had a complete desynchronization. So that was basically one of the things we realized, that using isolation with isol CPUs and task set, everything is basically running on one core and then interfering with itself. So we had troubles to manually load balance the cores, since the Linux scheduler and load balancer are not active then anymore. Therefore, using shielding seemed to be a better alternative for us. So we employed a CSAT shielding, and then the essential kernel threads are still running on the CPU, and we can employ a load balancing of the cores. So on the right, you can see with 2 cores, our results are slightly worse than expected. And then we looked at basically what threads were running, and there were over 50 threads running from ROS2 and OpenSplice DDS. So we thought it might be a bit much for just the 2 cores, and then we enabled 4 cores in the shield. And then you can see we got our best results with around 41 microseconds. So the stress didn't interfere much with that anymore. And yeah, to complete the system setup, we did a short network evaluation. There we used iPerf for TX and RX traffic. As previously mentioned, yeah, the RX traffic desynchronizes our PTP signal. Therefore, we should have that on a dedicated network. And in the TX traffic, since we are employing the Linux network stack, it was to expected that the latencies will grow with higher traffic. And maybe what's interesting is that it will change the traffic from 100 megabyte to 500 megabyte. It goes faster again, but that's due to the policy that the Linux network stack goes from interrupt requests to polling at 300 megabytes per second. So we have a different policy of how the incoming traffic is handled. Yes, as you can see on the right, it will decrease quickly once external traffic is enabled. So for real-time applications, yeah, it makes sense to just have the real-time communication set up by itself and everything else on a different network. So yeah, maybe now for the interesting part about ROS2. So there we did dig a bit deeper. As previously mentioned, we mapped the serial interface pins of the motherboard as GPIOs, so we could map them into user space, so we could directly address them from our nodes. And then we had an external measurement using the oscilloscope. So we basically measured the rising flanks of each GPIO and put that in reference to the PTP signal. So on the right, you can see, as previously mentioned, we have a remote publisher, a local publisher, which are basically both from our interpolator, both sending the same topic, and they are with an offset of 150 microseconds, so we don't have any racing conditions in between. And as you can see, we expect them to wake up a bit later since we already have a response time, and highlighted in the colors is the range of the jitter we are sort of expecting, but obviously we want to decrease the latency and the jitter. And then we have a local subscriber, which is just for this application, and the remote subscriber, which is basically a cross-network communication. And there we want to have the best results possible in our network stack. So once we employed everything, you already can see at the bottom, it's all over the place, and our results are not anything we expected. So this is on the previously optimized system with the out-of-the-box ROS2 installation of Eloquent Eluser and on a stressed system. Obviously, if you don't stress in the system, it doesn't look as bad, but this was taken overnight, and we will lose measurements, and yeah, basically, we have no guarantee that anything is remotely able to run in real time. So I will not go into detail of all the steps we take or have taken and what the results of any step were, but I will briefly talk about what helped us increase our time or decrease our jitter and latency. One of the key things was that ROS2 enables us to use different allocators, since the standard allocator wasn't real-time capable. Changing to the two-level segregated fit allocator helped by a lot. There we have guarantees for bounded times from the allocation, and furthermore we used pre-pooled messages, which is another feature which is possible to use in ROS2, and this already decreased everything by a lot. Then obviously it's not sufficient to just have the application in real-time priority, but all threads which are used in the communication have to be with a higher real-time priority, especially in OpenSplice. Our finding was that the XMIT thread had to be with a high priority, since that handles everything with the network communication. And furthermore, as previously already mentioned, the shielded cores are a good measurement to reduce the impact of the stress on the system. And as you can see at the bottom and in the table on the right as well, from the local transmissions via the loopback device, we have in the idle state a max of 136 microseconds. On a stressed environment, this decreases a bit, and even with shielding, it's still slightly worse. However, the shielding run was conducted over a time frame of a week, so we have around 12 million samples there. The other three results are originating from around 1 million samples during nightly runs. And from the isolation, we just measured from the local transmissions, since the remote case, we had the trouble that the systems got desynchronized with isolation, so it didn't really make sense to take these into account. Then from the remote case, in an idle system, we have 240 microseconds. Stressed system decreases that to 466 microseconds, and the shielding slightly improves around the stressed system again, which is the worst timings we are to expect. However, most of the timings are around the mean. So if you look at the graph at the bottom, we have outliers to the right, which basically result in our worst real-time cases. However, the mean is around 108 microseconds for the shielded case, which is the case we would suggest using then. So yeah, that basically brings me to the end of my talk. So this was a short introduction about the real-time capabilities of consumer-based hardware with ROS2. We had a brief evaluation of real-time systems, and especially we used an external validation. We didn't just use the system tools, but we measured it with an oscilloscope with a reference time. We had a brief evaluation of the network latencies. And to finally conclude, ROS2 needs to be tuned, but ROS2 can meet real-time requirements once needed. And how are we going to employ this in the future? We want to do an evaluation of basically a distributed and time synchronized real-time robot controller based on ROS2. So basically the whole pipeline you can see on the right, we want to have that in separate nodes so that we can tune each node and then have a complete non-monolithic robotic controller in the end. So yeah, thanks for your attention. And if there are any questions, feel free to ask them, I think now or maybe later.
Thanks, Leonard, for this very, very interesting insight into real-time capabilities of ROS. That was, really, really cool to see. I would say let's just jump into the next presentation. So our next speaker in this session is actually Kat from Open Robotics, who will talk a little bit about the current status of ROS2, or let's say updates, and give some transition recommendations towards transitioning to ROS2. So Kat, the floor is yours.
I'm Catherine Scott. I'm the developer advocate over at Open Robotics. Fairly easy to get a hold of over there. If you have questions, please let me know. So why don't we just start talking about ROS2? Oh, here we go. All right, so actually before we begin, I actually put a few bits of errata in here if you're unfamiliar. The first thing is that on ROS Discourse, I'm starting to do a weekly sort of rundown of all the ROS news. So if you want to know sort of what packages were released this week and what's going on, drop by on Fridays to ROS Discourse and we'll keep you up to date. If you are trying to do any sort of discussion about ROS or want to sort of convince particularly business-minded people that ROS is a good thing to use, I also compile a yearly metrics report that's super handy. It'll basically tell you kind of who's using ROS and how big the community is. So that's listed there. We just had our big annual conference for what we called it ROS World this year, and as of last week all the videos are up. So if you want more ROS related content, feel free to go check that out. And then one new thing in January, I'm going to start trying to pilot a sort of monthly community meeting where people just sort of hang out. We have talks, we might have like panels, maybe Q&A sessions. So look forward to that in January and please join us. So let's get started. Let's talk about ROS timelines here. So right on the left here is now, and actually yesterday we pushed the last Eloquent release, and so Eloquent is officially done. ROS2 Eloquent is no longer officially supported. If we look a little bit on the right, there's a tombstone. Kinetic, ROS1 Kinetic will basically be done in April. And then in May, dashing is going to go end of life. And then sort of concurrently, we'll be releasing ROS2 G-Turtle, which is not an LTS ROS2 version. And approximately 5/2022 will be the next big ROS2 LTS. And then a year later, we're looking at both Melodic and Foxy going end of life. And there'll be subsequent releases. And over here on the right, I have to move this. There will be, in 2025, we're basically, that's when Noetic goes end of life. And so what does this mean for users overall? The first thing that you really need to think about is that in 2023, when Melodic goes end of life, that will be the end of support for ROS1 plus Python 2. And then in 2025, that's the end of official ROS1 support. Now, this is official support by Open Robotics. People are allowed to go and continue using things, updating them. It's just the official support will end. And so the take-homes from this timeline are a couple. First is 2 years are basically left for Python 2 support in ROS. The second one is a little over 4 years are left to continue using ROS1. And what that means for you is that you should be thinking about migration, and you should be thinking and budgeting for routine maintenance and upgrades. And the sort of clock is ticking right now. And David Liu was kind enough to provide us with this countdown clock if you ever need a reminder about these dates. So as we continue here, the other thing worth noting is with ROS2, we recently started having a rolling release. And effectively, the rolling release is just your sort of daily development branch of whatever's going on. And then from the rolling release, rolling Ridley, we cut all the subsequent ROS releases. And the way you think about this is, if you're a developer, think of basically each ROS distro as being the main branch, and then rolling Ridley is effectively the dev branch. It's just whatever the latest and greatest is at any time. So let's talk about ROS2 and let's talk about Foxy. So as of this year, we have ROS2 Foxy. A couple months ago, Move It 2 was released for Foxy, and also Nav 2 has been released. So effectively, you have ROS, you have an LTS ROS2 release, and then you have all of the sort of big ticket ROS items that most people are looking for, or most people need. And a couple months ago, we actually surveyed the community with regards to RMWs, and I slipped a couple questions in there about just general feelings about ROS2. On the left, you may not be able to see this top graph, but the survey question is based on the out-of-box experience, would you recommend ROS2 Foxy to a friend? And the general sentiment, and this is about, I think, 96 developers, the general sentiment was, yes, I agree, or I strongly agree, which means most people are liking the switch. However, we also surveyed, are we providing enough information to make a sound selection to figure out the right RMW for ROS2? And the responses here were much more mixed. So people are enjoying ROS2, but they're still finding that there's not sufficient information for them to make the switch, or it's a difficult process. So hopefully we'll be fixing that, and I'm going to give you a few pointers on how to do that well. We asked a few other questions with respect to RMWs, and this one here on the left, the yellow one, says, has DDS and this notion of ROS middleware improve the overall ROS experience? And overwhelmingly, people were enjoying the experience. They think it's improved ROS dramatically. We also asked them as to whether their RMW is interoperating well with the other subsystems that they're using. And the general sentiment here was agree. There's still, from what we've heard, there's still some issues sort of figuring out how to use some kinds of hardware correctly, but by and large, people were enjoying the experience. From a sort of, one thing I often hear is that, well, I can't move to ROS2 because I'm missing sort of my upstream dependencies. And, generally, if you go and look at ROS metrics, you can see if you've checked out ROS metrics, basically here are the number of repositories that are currently in ROS distro. And this sort of slate blue one here is melodic. So there's almost 900 repositories currently in melodic. And then if you drop down here and look at something like Dashing or Foxy, there's only 232. I don't think this actually tells the full story, but this is sort of where we are in the transition process. So if you actually go look at apps, or like the Debs that are in apt repositories, it's not nearly as bad. So if you look currently with Foxy, we have 692 app packages, Noetics at 1139, and over here at Melodic and Kinetic, we're at 2152 and 2757. I don't think this tells the whole story. So the first thing to note is that most likely there's a Pareto distribution on sort of the use of different ROS packages, and the top 20% of ROS packages are used in 80% of the systems. And then sort of concurrently, the bottom quintile of packages are just sort of effectively abandoned, or therefore, graduate student projects that didn't go anywhere, or they're startups that went out of business. This chunk, this bottom quintile, I don't think is ever going to get moved over. So discount that. And then also, if you look at these, 692 is a fairly large number if you consider that it's mostly these larger, bigger ticket packages that people really are using all the time. The other thing worth considering is that basically Noetic and Foxy came out approximately at the same time. And we believe that this sort of transition process here in the center, Noetic, sort of foreshadows what's going to happen to Foxy. So people have moved over to Noetic, and soon they'll be over at Foxy. So let's talk about the two types of sort of software development. On the left, I have the mythical land of continuous integration and continuous deployment, where people are doing daily deploys and nothing ever goes wrong, and software engineers are very, very happy. And then on the right, I have the project dungeon, where you basically wrap up one project and you're whipped by another ROS upgrade and you can barely keep up. Generally, what I see in the manufacturing world is the one on the left, this mystical land of CI and CD doesn't really happen, right? Continuous deployment is very terrifying in a manufacturing setting. Like, these things are very well tested, and once they're tested, they usually get fixed, or it has become a fixed system. And so the testing tools aren't there. People don't really have the cycles to do continuous integration, continuous deployment, and it's really a pattern for sort of web developers. Over in this sort of dungeon of painful development, people are looking and say, well, the longer we wait, the more packages there will be. It's not really worth us to, move to ROS2 until the absolutely last minute. The project that they might be touching might be something that was developed 5 years ago, and the person has moved on, and they don't want to go and actually dig into the code because they don't know what's there, and they've got other fires going on, and there's just general concerns that something's going to break. And so I feel like that's sort of the situation most people find themselves in, and are not really trying to shoot for this sort of land of continuous integration, continuous deployment with ROS. And my hope is that most organizations can actually get somewhere in between, in the sense that, well, maybe they're not doing continuous integration, continuous deployment, but they're once a year, twice a year, regularly checking in with the ROS distro and making sure things are up to date and doing regular updates. And that's where we'd like everyone to sort of get to. And to get there, organizations need to accept that, upgrades are good. There's a apocryphal story about people going into manufacturing lines, and because something's a capital expense and hasn't been upgraded in 10 or 20 years, it's still running Windows XP in 2020 or 2019. And you don't want to be that organization. You really need upgrades to make sure your systems are secure and reliable and robust. And generally, doing these sort of transitions shouldn't be difficult if if your tech debt is fairly low, if your tests are there, if your deployment systems are there. It really shouldn't be that difficult to upgrade. Developers also need to keep in mind that open source isn't free. You will need to basically spend time and money to upgrade systems and to proactively budget for the time to do that. And you may even have to help out other development organizations. But on the flip side, all of these timelines are public, and there should be no surprises about when you have to do this by. So let's talk about ROS2 transitions. The good news is that, like I said before, all of the big ticket items are in ROS2. Most of the top 500 packages are in ROS2 already, and there is a clear pathway from getting from ROS1 to ROS2. And I think the thing that's missing right now to get people where they need to be and to get ROS2 where it needs to be is developers need to communicate their needs with respect to upstream packages and bugs and issues that they're finding. If people say, we're budgeting our time to go and do our transition in 2022 in the third quarter, and then they go to their upstream packages and say, hey, we're doing this then, what do we need to do to get there? Things should go relatively smoothly. So a couple weeks ago, we surveyed ROS users that are using Kinetic, because Kinetic's going to go end of life in Q2 of 2021. And we asked them where they were going. And most of them actually said, about 40% of them said that they're moving to Foxy from Kinetic, which is pretty amazing. And then about a quarter said they're going to melodic, and a quarter are going to noetic, and about 6% of the respondents are saying, no, we're just going to stay on ROS kinetic. So before you begin your transition, the thing that I think is most important to think about is just general code hygiene and code quality. So in ROS2, we have Rep 2004, which is the code quality declaration, which sort of says, hey, please list out these sort of aspects of quality and where you are with respect to sort of benchmarks that we've set. And the reason I think it's really important to think about code quality before you begin transition is that clean, well-tested code is much, much easier to transition. It's a lot easier to say, if I'm going from kinetic to melodic, you do your upgrade or you do your nominal upgrade, run your unit functional integration tests, and if everything passes, maybe it was a very, very easy transition. And all of this to say, if you don't have unit tests, you really ought to spend the time doing that first. So our suggested path for transitioning out of melodic and kinetic is to first go through noetic. And the reason for this is that transition gets you through the Python 2 to Python 3 transition. And if software developers at your organization aren't begging to move over to Python 3, something might be wrong. Once you go through that sort of eye of the needle of the Python transition, you have a tool called the ROS1 to ROS2 Bridge that should help you get from noetic to Foxy fairly easy. And there's a good number of systems out there right now where, half the system is currently running noetic or even melodic through the bridge, and then the other half is at Foxy. And what this should allow you to do is sort of in a piecemeal fashion, move one package, then another package, then another package until you've finally moved all the way over to Foxy. As I've mentioned, the bridge is a pretty good resource to do this. The documentation seems to be okay. You can find it over here in this right link. There's also a talk from ROSCON in 2019 where Mabel, who I believe is one of the core devs for the bridge, actually walks you through step by step how to use it to do a transition. Another problem I hear a lot about is just what I call the chicken and egg dependency problem. So your organization may have like an upstream dependency and you're waiting on them to transition and they're waiting on one of their upstream dependencies to transition, and it just keeps cascading. And invariably when I ask, like, well, if you're trying to do a transition, did you communicate with that upstream repository or that upstream developer that you're trying to transition? And they say, no, we didn't talk to them. We just assumed they're going to do it. And I think it's really, really important to go and communicate what your plan is and when you plan to move over. And just saying we're going to transition is good. Just filing a ticket saying, when should we expect an upgrade is fine. You should also be willing to review code. You should be willing to make PRs to these upstream dependencies. And I also think it's really, really important to ask, what does the individual maintainer need to get that transition done? And once you figure that out, like if you have to budget more time to help them out or to make it happen, then that might need to happen. There are also a small collection of people who are willing to help upgrade certain repositories. There's a link below. Steve Mazinski's been looking into this. Feel free to use ROS Discourse to discuss upgrades of various packages. One thing that people encounter is that some packages might be replaced with some other library and sort of deprecated. So understand if that's happening or not. And then finally, if you've come across an abandoned package that you do need upgrade, please come talk to us. We might be able to help out with that process. So let's talk about a few of the complaints that people have had or problems that people have had in transitioning from ROS1 to ROS2. The one I hear most common is issues with ROS serial. So the sort of general recommendation for ROS2 is that, we're slowly trying to move people over to micro ROS so that they're sort of running native ROS code on their embedded microcontroller. That is a fairly, transitioning firmware is a difficult thing, so you may not want to do it, and I don't think you necessarily have to. There's also the ROS serial bridge, So if you have a system running ROS serial and you want to upgrade it to ROS2, that serial bridge should be able to help you out. Another common pitfall that I hear about is just general Jetson NVIDIA support. Unfortunately, Open Robotics can't address this for NVIDIA, but my belief right now is that they're actively working on this and it should be fixed fairly soon. Sort of in the meantime, NVIDIA has released basically a Foxy Docker container running on 1804 that was all built from source. They say it isn't that difficult. I've heard it's not that bad. So if you need sort of a Band-Aid to get there because you need that hardware support, they should be able to help you get there. Another thing that I hear fairly often with respect to hardware and ROS2 is the RealSense driver. So currently the ROS2 RealSense driver supports stashing and Eloquent, I believe. There is a ticket out there where people are asking for Foxy support. I would really recommend that if this is something that you need, go, let people know. Go chime in on that ticket. For other hardware, and particularly for hardware vendors who might be out in the audience, we're recommending that if you're targeting releases, target Noetic and Foxy at this point. If you have a hardware vendor and you're waiting for them to perhaps upgrade, you should communicate to that. You should reach out to them and say, hey, we're looking to upgrade to ROS2. We're targeting Foxy. We're targeting this other release. When do you plan to have that done? I'm also more than happy to help talk to vendors for you, just sort of on behalf of the community, say, like, we have this many ROS developers that use this piece of hardware. I can go, how can we help you get to the point where you're supporting the latest and greatest ROS release with your hardware? So another thing that I hear a lot about ROS2 transitions are people still kind of leery about DDS and ROS middlewares. And the thing I hear most often is, well, what's going to be the next default or ROS2 middleware? Or what's going to be the next official ROS2 middleware? And the sort of general consensus is there is no official ROS2 middleware. There are defaults for each releases, and those defaults may change between releases. And people seem to believe that the default RMW has better support, and that's really not true. We try to support all of the tier 1 RMWs out there. And if one isn't working for you, it's fairly easy to change. It's only a couple commands. If you're still trying to figure out which RMW you might want to use with your application or you're having issues, I've actually put together a fairly substantial, or the team at Open Robotics has put together a fairly substantial report on the performance of different RMWs, and it's fairly comprehensive. We've done network simulations, we've done real world simulations. We've asked the community members, we've looked at sort of general code quality metrics, and they're all in this report, and you can get a sense of what RMW would work best for you. I also wanted to share some stories about people who have transitioned. So on the left is our official guide for ROS1 to ROS2 transitions. Also, Husarian Robotics and Rover Robotics have gone through the transition process, and they wrote about it, and I think they have some valuable insights. Also, ROS Industrial has done the same, and I think they have some good feedback on what to do and how they approach the problem. So you should check those out before you begin. I think they're very, very helpful. As I mentioned before, there is sort of a community-sponsored porting list out there. So if you are looking for help getting a package transitioned, you might want to add your name to the list and sort of bump that thread. I think that should help. And finally, as I said previously, I really, really want to encourage you to use ROS Discourse to sort of talk about your ROS2 experience, to talk to other developers and reviewers that might help you transition a package. If you want to fork abandoned packages, this is a great place to say, hey, we're doing this. It's also a great place to recruit if you need an extra set of hands to help you in the process. And, there's also a fairly often there's discussions on sort of what people are doing and the best practices in transitioning to ROS2. So don't be shy. Visit ROS Discourse. Please come talk to us. Yes, and that's it. So please move your code to ROS2. And I think, do we have time for questions or not?
I think, Kat, we can have the questions in the panel session afterwards and discuss them mostly together.
Okay.
But, well, one question was, we can maybe go for one question right now. One question was about your user experience study and whether you have cross-reference with the number of years the people that answered were using ROS1.
So in the report that is not, I don't think we specifically call that out, but that data is actually there, and I anonymized and open sourced all the data. So if you want to go check that out, there's actually some Jupyter notebooks in there too, where it should be fairly easy to suss that out. We did report the distribution of years using ROS, but we didn't sort of tie that back to experience.
Okay, yeah, great. Thanks, Kat. And thank you for the wonderful presentation and also for getting up that early for us. And let's go on with Matt from Southwest Research Institute, our manager of the ROS Industrial Consortium Americas, and his presentation about, well, delivering open source into production. Matt, the floor is yours.
Good afternoon, early evening. So anyways, my name is Matt Robinson. I'm going to share a little bit kind of what's going on in ROS Industrial in the Americas. So hang tight. We'll share a little bit of insights of some things we've been working on. Some of this may seem familiar, but bear with me. So as Christoph alluded to, we're based at Southwest Research Institute, the ROS Industrial Americas Consortium. And so we're a nonprofit R&D, applied R&D center down in the southern United States. We work across our campus in the physical sciences, and we like to say deep seed, deep space, due to the breadth of things that take place here at the Institute. That being said, here a long history at the Institute in my department, specifically developing advanced robotic applications. And a couple examples are here on the screen. And I just wanted to point out, right? So because we live and breathe robotics and building first of a kind solutions, having the flexibility that ROS offers is very paramount to the work that our team does here, right? So ROS Industrial has been a real enabler in enabling us the flexibility to work with industrial OEM COTS hardware like this Yaskawa industrial manipulator pictured above, as well as then, of course, working with custom robotic solutions like the one pictured below. And again, we like to touch on this and remind people, right, ROS Industrial and what we're seeking to do. I came from Caterpillar after 14 years. We really struggled extending the capability of industrial robots to new things. There was a long history, of basically robotics being applied to basically if you have a lot of the same thing, but how do you get into high mixed use cases? I think in general now everyone understands that if we want to do a lot of different things, ROS is a very useful tool, particularly also if you don't want to be vendor locked. The good news is we are seeing robots start to, and this is RIA data on robot sales and what they're being applied to. And we are seeing in general a trend uptick in doing things beyond these traditional industrial areas. The other thing that there's been significant growth is in handling. And I don't think there's much surprise in that. And I think we can contribute the evolution and adoption and advancement of open source tools leading to the surge and new handling capabilities that are showing promise and obviously tangible growth on industrial applications. So that's super exciting. So a number of you are familiar with the consortium and what we do. The big thing from our consortium membership is to provide feedback and help give direction to what we're focusing on, right? And so it's no secret, those of you that are intensely engaged in the European work, and Rosen in particular, understand this, right? So we've been focusing on quality. You mentioned, Kat talked a lot about user experience, right? So on the industrial side, it's a slightly different user experience depending on who the user is, right? So the systems that are deployed in, say, a factory have a number of different users, right? So how do we talk about each one of them and what that experience is? And of course, obviously, we want robots to do new things. So we've been focusing on these 4 verticals more recently based on the feedback from the membership, and we're happy to kind of share some things there. We are also interested in ROS2. Kat was kind enough to mention the write-up over on the ROS Industrial website for some production deployed systems that are basically running around a factory today. And we learned a lot, right? And it was a very good exercise. We were happy to both realize the capability and of course provide feedback to the community. But one thing that really helped us also test was this strategy that we've been trying to employ. I think for those of you that are tied into the industrial paradigm would acknowledge just because something is out there for a little while, it doesn't mean it's not expected to be supported to some degree. So as we think about solution providers that want to leverage ROS, in our group specifically, right, we have ROS systems that have been in production since 2014. They would like new capability, right? They would like to, if we make an improvement to a motion planner, hey, can they adopt that? And now that we're trying to kind of basically keep the core library separate and then provide wrappers, we have some line of sight to do that. It is not without its challenges. There are peculiarities relative to how effectively you're able to do this. But in general, this model has served us well for a number of the different packages and repositories that we maintain under the ROS Industrial banner. And so the other thing that we've been really concertedly growing in the last couple of years, I know we've touched on this topic and this success story with Bastion Solutions. I think myself or my colleagues here at the Institute in Americas have touched on, but in general, right, we're trying to grow solution providers that service industry end users to consider ROS for developing their advanced applications, right? And we have now grown a suite now of the right kind of partners, if you say, right? So we talk about ROS Industrial and the repositories in there as sort of an enabling foundation. We have these components. You hear people share their experiences developing, like say, a specific repository or an example implementation application. And I'll touch on one of those in the future. Ideally, right, we then work collaboratively with integrators or solution providers to turn these into things that make a difference on shop floors. And we're seeing more and more of that, and that's exciting. One of the big things that's really taken off is the phrase scan and plan, and it's basically a family of ROS-based applications that started with a proof of concept in 2014. Those early adopters have since implemented a high mix painting solution around that time. It's the 2014 system I mentioned, it's in production, but obviously things have evolved significantly since then. End users that do high mix operations that just want to like throw the parts into the work envelope and have the system work are very attracted to the capabilities we can realize through these ROS-based systems. We've leveraged and made a lot of enhancements to a number of the ROS Industrial family of repositories, and this is just a handful. In fact, I can't speak to SDXML and YAC in particular have been real enablers for basically both accelerating and standardizing development, as well as providing enhanced capability. YAC, yet another Kinfu, as a reconstruction library that helps us manage, for instance, if we're dealing with machined components or things that have been polished, right? It gives us meshes dynamically at the frame rate of the camera. But this has also been an enabler to do localization of things that don't have a ton of detail, right? So if you think of like an airplane wing, for instance, it's lots of long, flat surfaces. We can get much higher performance localization just by, like, say, doing this like reconstruction of just the extents of an airplane wing, and boom, we have really high performing localization, enables us to do a lot of different processing. And that's been a really useful tool. More recently, we've been making further improvements to Nether by including this heat method planning library. And this is really exciting. And I believe we already have an implementation fully open sourced. If not, it's very close. And this will work not only just on meshes provided out of, say, YAC or a mesh that you provide from any other source, but we'll also hopefully have an implementation working on point clouds for those, like, say, for instance, if you're using the PhotoNeo camera, where you have a very nice refined point cloud. And the idea here is that we want evenly spaced rasters, across arbitrarily contoured surfaces. And so this applies a heat method approach, right? So in thermal, if we apply the laws of thermodynamics, if I apply a heat source, the isotherms are evenly spaced, and that's what you get here over arbitrarily complex contours. And this is a really nice enabler for when we want to do painting or precision polishing and sanding applications. So we're excited to offer this up to the industrial community. We've learned a lot of lessons the past couple of years. I think we talked pretty intently about this specific application at the time, but what we're doing now is actually trying to incorporate in a lot of the motion planning tools some different means to more intuitively manage the constraints for complex processes. The pictured system here carries 7 processes. It's got complex festooning because of the utilities required for the processes. You need to be able to accurately model these and incorporate them into your motion planning so you don't damage all the tooling, right? So how do you do that? This is a complex sort of motion planning scenario for when you're trying to like carry a lot of payload on the end of a robot arm. It basically restricts the manipulator's free space. So we've been further refining and getting feedback from the user community at these deployed systems, and people are using the suite of tools around the systems to basically further refine how we actually can do the constraint modeling, enable the tuning of the constraint modeling to then feed into the optimization-based motion planning. And so this is, again, some further tools and have been made available, enhancements, and for instance, in this case, Tesseract, but also like, these can easily be applied to other motion planning environments. Kat shared a little bit about our experience of ROS2 into production. I figured I would touch on it a little bit here. We did actually have that similar experience where we had to experiment with the RMW, and it was pretty painless, right? And so I included the text-based link here for those interested in kind of understanding, what we learned of creating specific ROS2 packages and how we leverage the bridge. We've now incorporated bridge implementation in our ROS2 training because in the industrial space in particular, the bridge isn't going anywhere anytime soon, right? The hardware interfaces are sort of the latent or slow gazelle in the ROS2 transition journey. But at the same time, we are able to realize really decent and actually very, very good capability leveraging ROS2. We more recently just concluded this project, so this is relatively recent, a collaborative project of some work funded by the Advanced Robotics for Manufacturing Institute. So it's sort of like a US ROSIN, if you will, that's cost share driven as well, working with Spirit Aerosystems and Wichita State University and some team members out of Southwest Research Institute to make a completely open source ROS2 application. So I mentioned we had a production implementation. Well, unfortunately, that was for a client that was not so open to fully open sourcing it. So we're happy to take advantage of this application and fully open source this particular implementation. The end goal is, historically, there has been some robotic sanding in aerospace on composites in the past, but Spirit Aerosystems works in a very high mix environment. And they still would like to have their people be involved in sort of monitoring the process, doing the detailed finishing, think of the 80-20 solution. This is where kind of human robot collaboration as an idea can potentially shine if you want to operate this way. And so a couple different things we had to implement. One is that they basically wanted to take advantage of, force feedback to apply the sanding applied pressure. That is a key parameter for their process. So we took advantage of the FCI Cartesian controller and basically made it so we could command a force and a velocity, because those were the two key parameters for the composite sanding process. And so here we created a hardware agnostic implementation leveraging the compliance controller to basically do velocity commanded constant pressure trajectories. The other element that had to be implemented that's also included in this collaborative robot sanding application is the ability, we have the operators. So the operators will basically, once the robot does a region, the operator will come over, check it out, and with their Sharpie, they will annotate the part. And the idea is like, hey, it has to be just a closed loop boundary. And so we developed that library to basically enable that operator and then the system to recognize those closed loops and just process within the closed loops. And so we're very excited in October to be able to demo this system. Obviously, due to COVID, the big demo across for the whole institute and the technical stakeholders had to be virtual. But we had staff go to the deployment site, work with the Spirit Aerosystems staff, as well as the staff at Wichita State's NIAR lab to basically also get them familiar with the repository, train their operators, and then of course they executed technology ready level 6 level testing. And it was deemed like, hey, if we're gonna operate in this form, i.e. leveraging the manipulator to apply the force, because there are some limitations in operating that way with industrial manipulators, that like, hey, this meets the expectations or the requirements of technology ready level 6, right? So we're very excited to see what Spirit Aerosystems does next with this solution. And so we're very excited to see it get through there. And this whole video is out there. I've included the YouTube link for those who want to go view it. But yeah, it works through the whole workflow. It's unfortunately a long video, so in the interest of time, I'll move on. But it also includes the operator and the human marked regions as well. So some different things we have going on. I wanted to touch the consortium, right, is very interested in fostering collaboration initiatives amongst the membership, right? So very recently, Picnic was inquiring about, hey, let's try to get a proper ROS2 interface going with Universal Robots. And so with working with Haish at TU Delft, team helped make some introductions with folks at FCI Research and Universal Robots. A collaborative initiative has been brought to the fore and has been initiated to create that ROS2 interface led by Picnic, right? So I want to shout out to Picnic for them taking the initiative, putting in the sweat equity, and obviously the teams at Universal Robots and FCI Research and working with them and providing them guidance and moving forward with that work. Another one that's been interesting is taking a look at a tighter, more efficient workflow between Simulink and ROS control, and that's with MathWorks and under the guiding eyes of Haish at TU Delft. So that's pretty exciting. And there's been some recent work between the ARM Institute, who's a ROS Industrial Consortium member, RPI and Watson Technologies, and as well as Southwest Research Institute, looking at Robot Rocketeur and extending it to play nicely with ROS, but advocates it as a tool that's a plug and play framework to kind of stitch applications together. That's a little bit more lower barrier to entry than some people feel ROS is, right? So we were happy to support that team and develop some interoperability with ROS-based systems using this Robot Rocketeur software system. So feel free to Google Robot Rocketeur. It's fully open source as well. It has a pretty baked out website, and there's some utilities there that may be of interest. There's also relative to some recent released work on real-time planning. There's a write-up there. I included the link, so feel free to check that out. More recently, in the idea of the industrial end user community, very interested in kind of just grab and go. This has been something we hear from industrial end users quite a bit, that they're very interested in, like, say, hey, I like the idea of the capability. You guys make great YouTube videos, great demos, even when we come and see them in person. But at some point, like, I would like some basic functionality that doesn't require a lot of working on the command line, right? So we've been taking a look at both deployment methods as well as like what can we do through kind of more menu and GUI driven tool sets, right? So we've been investigating, playing around with a snap deployment. We put, this is basically the Tesseract setup wizard, which is built out on Ignition and in testing, delivering it via snap package, right? So we've had some people do some test application setup and seen some benefits. And we're looking at extending this capability a little bit and getting it in more people's hands to get some feedback to some of our kind of industrial end users that are a little bit more dangerous and open to testing this sort of vehicle. Some other more recent developments have been doing some more detailed processing, right? So we start talking about aerospace, we start talking about applications to where we're looking for things at the sub-millimeter level, right? So what are some enhancements we can do? What level of post-processing analysis or in-process analysis do we need, right? So combining some of these dynamic reconstruction techniques, these are obviously airplane propellers, as you can see. They come from the field, they need to be dressed and surface finished. So there's some active work there, taking a look at like, hey, what can we do here for remanufacturing for aerospace use cases where we can combine these tools to basically create a very flexible system that parts can be arbitrarily presented. We can localize them, we can process them, and we can understand the state of the process and how well they're working at aerospace kind of expectations and requirements. So that's been some very exciting work, and we look forward to kind of putting out a little bit more, let's just say, meat on the bone here in the coming months. So stay tuned. Some other takeaways, right? We try to hit this. ROS-based systems, they're out there and delivering value on shop floors. I don't know if that I have to really espouse this to this particular audience, but there are certain where I do. There's still a perception in many circles where the ROS developed solution is still very much a lab solution. But we're always trying to hit the nail on the head, so to speak, that we're in factory floors, we're doing this work. We're also doing it with ROS2. Right. So I want to echo Kat, like if you have the opportunity, if you're just getting started with an application development, please consider ROS2, right? Like, again, I understand if you have a lot of legacy history, or like say you're in a startup and you're already down the road quite a bit, you may be hesitant. But where you have, like, say, a fork in the road where you're going to start something new, it's a good chance to jump on the ROS2 wagon, so to speak. It gets better when we all start contributing. And also, industry is hungry for new capability, right? And I don't think it's any secret that ROS is sort of peaking, right? And we're getting a new level of robustness relative to ROS2, and the potential is even greater, right? So keep in mind, we still have this idea of leverage of reusable blocks, right? So we're continuously trying to refine the core repositories. I know we also are struggling with getting certain things ported over. I saw on Discourse recently a comment about some of the core ROS Industrial core, for instance. We're still trying to catch up as well, but feel free to hit up on Discourse and keep the conversation going. We have this ecosystem, right? The idea is like, hey, we don't know what makes a difference unless end users speak up. So we're also trying to educate the value of Discourse to our end user audience who's not necessarily so familiar with Discourse. So when I deal with the consortium membership where they're kind of more, let's say, on the shop floor focused, I have to kind of educate them that Discourse is a thing. And it's not just for developers. So it's obviously still very developer centric, but they as end users can express what works, what doesn't, what has been a challenge, and that helps. That be part of the community. And we're still working with our industrial members to embrace that. And of course, obviously, more resources, right? And these resources take the shape of tutorials, actually open sourcing full applications, right? So that collaborative robot sanding one, it's out there as a full application, right? And we believe that's a good learning tool that, like, hey, you can build a full ROS2 application, and this is kind of what it may look like, right? So we've already had one member build that. We had some trouble in sending feedback and logs, and that's very helpful. That moves the ball forward, right? So we want to engage more end users, give them tools around training. We're currently working across all of our regional consortia on training, so we look forward for more information coming out there and diving into ROS2. Again, I don't have to necessarily share this with this community, but these are the resources. We look forward to anyone poking around, kicking the tires, and giving feedback. With that, that's who I am. And hopefully we have time for panel. Christoph.
Thanks, Matt, for the nice presentation. Really interesting. So let me just order my thoughts. Okay. So Matt, we have directly one question for you. From the audience. So they are asking actually about delta kinematics and support. Can you give a statement on that, and especially if there is a plan to have support for this in ROS2?
So what kind of kinematics? Can you repeat that?
Delta.
Right. So, obviously, unfortunately, unless someone comes with a specific hardware and or use case, we don't necessarily have the ability to dive into it. We at one time had a Delta bot in our lab. It, I would say, has been fully decommissioned at this point. So unless we have a member who's really interested in or an application at this time, without some physical hardware, we'd be hard pressed to sit there and indicate. In general, we have run some test cases with IK for Delta, and I'm just saying it's not probably fully done yet, but I'd say it's close, right? So we have a couple different kinematic models for Delta applications, but because we don't have hardware, we've been hesitant to, like, say, fully put them out there. But there's nothing, say, precluding Delta kinematics from being available.
Matt, we should chat on that one. I got an idea.
Yeah, no, we have another group that's actually working on it.
Oh,
It's
okay.
just I just am not plugged in on a day-to-day basis of where they're at. So, but it shouldn't be too far.
All right. Okay, in the chat, we also had some discussion about TSN and DDS helping real-time performance. Maybe Leonard, can you give a statement on that?
Yes, since it's my understanding, DDS and TNS is just with Connects, RTI Connects DDS so far, which means it's not on a royalty-free DDS version. So we didn't really look that deep into it. But I would suggest that it's probably increases or decreases in the latencies. So it might be beneficial for real-time applications. But yeah, we didn't really dig into it since it's with Connect, and we used OpenSplice in our application.
All right. Maybe some info for Kat. So we had some small poll running here, and I think that kind of concurs with what you said about switching to ROS2. Mm-hmm. So here, at least in the audience, already 20% went for it, and next year I think we'll see a lot of people going for it. So there's another 45% that plans to do that next year. Is that the general view that you have of the ROS community, so that some people have already done it and most people are planning to do it next year?
Yeah, that sounds about right. Like, we've been in this weird spot, and I think with Kinetic going end of life, right? Like, people, I don't think there was a huge motivation for people to move over to Melodic. It was just kind of like, there's a few things, but it's gotten pretty mature. And I think with EOL on Kinetic, I think it's really going to start taking off. And quite frankly, I think it's there now. Like, I think it's ready. Like, dashing, it may have been a little hard, but Foxy seems to be working. People have it deployed. So.
All right. Matt, your experiences with ROS2? So I know you have already implemented some applications there.
Yeah, no, it's been pretty good. I'm hoping we have another chance to, we have a real huge narrative that we shared via a NASA funded project on a real large port for ROS2. I'm hoping we'll be able to share some of that via some of our ROS Industrial Communication challenges. We have to get approval. But in general, our ROS2 experience has been very favorable. As Kat indicated, starting with dashing, things really took a turn, and we were able to do a lot. There are still some things in, like, say, motion planning for manipulators. It's still fragmented as far as, like, what specifically you're trying to do and what are all the full tools available to you. In which case, we have one recent application we had to pivot back to ROS1 just until we do some more backporting and then pivot back to ROS2. So, but in general, right, our experience has been very positive, particularly, like starting at dashing and forward, it's been pretty smooth. So we're pretty excited to continue to deliver our default position. Every new application comes in, we default ROS2 unless there's some real roadblock that forces us back. So no, it's been very positive.
That's actually the same for us. But Leonard, how is your estimation on, or maybe did you actually have a comparison between ROS1? So I mean, you could do some things to make ROS1 a little bit real-timey. How much is how good is the improvement in ROS2?
We didn't explicitly check both versions against each other, but yeah, in the general introduction I made, it's basically applicable for ROS1 as well. However, the improvements, especially with regards to stability, there have been papers earlier as well. So by interest, just let me know. I can send you in the papers who already evaluated ROS1 against previous ROS2 versions. I'm happy to share papers of colleagues who did that research before. So yeah, it seemed to be more fair and in general lower latencies across local and network transmission, and provides intra-process executors as well.
All right, yeah, great. Thanks, Leonard, also for these insights, and thanks to you all speakers. I think we're running out of time right now, so thank you for the presentations, and thank you very much for attending. I will shortly have a last statement for the conference, so just stay tuned with me. Essentially, I just wanted to end with the presentations that we started with. Essentially, so in keeping with with the spirit of my introductory presentation, I hope the conference has helped you to be less lonely as a pioneer in robotics, and that you see how ROS and ROS Industrial can make your life easier. And I think right now the conference has really shown that we are currently conquering industry with ROS. And my main takeaways of the conference really are, on the one side, that we are approaching real-time performance. So we heard that from Leonard, and before that from Bosch. And plus, security is being tackled in ROS2, even though DDS might still have some underlying weak spots that need to be, well, tackled. And we saw also very many cool new tools, or tools that were there with new features for visualization, manipulation, control, planning, or other problems. And the software quality is improving as far as we can see. So there are a lot of tools out there for testing and checking whether your ROS packages are good quality. And by the way, at least here at IPA, we have seen really some horrible code also in proprietary software. So that is actually not a problem that is explicitly there only in open source software. And not wanting to excuse anything here, but I think the only difference here is that in open source software, it's plainly visible, and in closed source software, it is not. And yeah, so I think ROS is going to industry. We had many examples from different companies during this conference, like Robotics, Pills, Suits. I cannot count them all. And if you want to see even more, there's the video competition. So I think it was a very nice conference. Thank you all for joining, and I hope you enjoyed it. Thank you very much, and see you hopefully next year in person again. Thank you, everyone. Bye.